This is Simplified Mathematics. Today we will be looking at decimal. Decimal is pretty much a type of numbers that contain a decimal point. For example, 0.5 here is a decimal, and the decimal point is right there in the middle. We usually use a decimal to indicate a number that lies in between two whole numbers. For 0.5, it lies in between the whole number 0 and the whole number 1. So 0.5 is larger than 0 but still smaller than 1. How about 2.7? This is also a decimal, and the decimal point is in between the number 2 and the number 7. 2.7 lies in between the whole number 2 and the whole number 3. So it's larger than 2 but still smaller than 3. Decimal can also be a negative number. For example, minus 3.2, and its decimal point is right there in the middle. Minus 3.2 lies in between the whole number minus 4 and the whole number minus 3. So it is larger than minus 4 but still smaller than minus 3. Now let's take a look at a larger decimal, 532.971. The decimal point right there in the middle can separate this number into two parts. The left part is called the whole number part, and the right part is called the decimal part. Let's first take a look at the whole number part. Each position in the whole number part has a unique name. The number 2 is in the position called ones or units. Some may actually call it ones digit or units digit. And the value of 2 in this position is 2 times 1, which is equal to 2. The next position is called tens or tens digit. And the value of 3 in this position is 3 times 10, which is equal to 30. The next position is called hundreds, and the value of 5 in this position is 5 times 100, which is equal to 500. You may notice that if we add up 500, 30, and 2 together, we will get 532, which is the value of the whole number part of this decimal. Now let's take a look at the other part, the decimal part. For this part, we also have unique name for each position. This is 10th position or 10th digit, and the value of 9 here is 9 times 1/10, which is equal to 0.9. The next position is called hundredths or 100th digit, and the value of 7 here is 7 times 1 over 100, which is equal to 0.07. And the next position is thousands or thousandths digit, and the value of 1 here is 1 times 1 over 1,000, which is equal to 0.001. And if we add up this part, we will get 0.971, which is the decimal part of this decimal. Knowing the names of these positions can actually be useful. For example, when we try to round the numbers. Before we round a number, we have to choose the digit that we are interested in. And then we look at a number on the right of that digit. If that adjacent number is 5 or more, we increase that digit by 1. But if it's less than 5, then we leave that digit alone. Let's take a look at some examples. For this one, let's round 17382.3 to the nearest tens. First, we have to choose the digit, and they are interested in the tens digit. And it is the number 8 for this case. The number on the right of 8 is 2, which is less than 5. So we're gonna leave the number 8 alone and the rounded number is gonna be 17380. How about rounding the same number to the nearest hundreds? This time they are interested in the hundredth digit, and that is the number 3. The number on the right of 3 is 8, which is more than 5. So, we will increase the number 3 to 4, and the rounded number is 17400. Now let's try rounding the same number to the nearest thousands. Now they are interested in the thousandth digit, and that is the number 7. The number on the right of that 7 is 3, which is less than 5. So we will leave that 7 alone, and the rounded number is gonna be 17000. Now let's try rounding this number to the nearest tenth, and in this case it's the number 2. The number on the right of that 2 is 3, which is less than 5. So we will leave that 2 alone, and the rounded number is gonna be 2.2. Let's try rounding the same number to the nearest hundreds. In this case, it's the number 3, and the number on the right of that 3 is 6, which is more than 5. So, we're gonna increase that 3 by 1 to 4, and the rounded number is gonna be 2.24. How about rounding the same number to the nearest thousands? This time it's gonna be number 6 in that digit. Since the number on the right is zeros, which is less than 5, we will leave that 6 alone, and the rounded number is gonna be 2.236. Now let's try rounding the number 2.64575 to the nearest hundreds. This time is the number 4 in that digit, and the number on the right is 5. So we will increase the number 4 in that digit by 1, and the rounded number is gonna be 2.65. Now let's try rounding it to the nearest thousands. This time it is 5 in that digit, and the number on the right is 7, which is more than 5. So we are going to increase the number 5 in that digit by 1, and the rounded number is gonna be 2.646. Certain standardized tests seem to love to play with this concept, so try to practice a little bit more until you are comfortable with this. Now let's try to take a look at how we can shift the decimal point. This can be done when we multiply or divide a decimal with a power of 10. For example, 10, 100, 1000. When we multiply, we can move the decimal point to the right, and when we divide, we can move the decimal point to the left. Let's take a look at what this means. Let's say we have a decimal number 264.5751, and it is multiplied by 1000, which is a power of 10. Or it is multiplied by 10 to the third. Since there are 3 zeros here, we can move the decimal point to the right 3 times. So, the answer is gonna be 264,575.1. Now let's try multiply the same decimal number by 10,000, or 10 to the fourth. Since we have 4 zeros here, we can move the decimal point 4 times to the right. And the number or the result is gonna be 2645751. Now let's try multiply by 100,000, or 10 to the fifth. Now we have 5 zeros. 1, 2, 3, 4, 5. So we can move the decimal point to the right 5 times. And since the last spot basically have nothing, we can just add 0 there. And the result is gonna be 26457,510. So that's how we do it, how we shift the decimal point. If you multiply by the power of 10, move the decimal point to the right. Now let's try dividing a decimal by a power of 10. We're gonna try to divide that decimal number with 10,000, which is pretty much the same as 10 to the 4th. It can also be written as multiplying 10 to the negative 4. Alright, this time we divide the decimal number by 10,000, which has 4 zeros. So we can move the decimal point to the left 4 times. And the result is gonna be 2.589763. Now let's try dividing it by 100,000, or 10 to the 5th. Or we can write it as multiplying 10 to the minus 5. Alright, so this time we're dividing a decimal number by 100,000, which have 5 zeros. 1, 2, 3, 4, 5. So we can move the decimal point to the left 5 times. 3, 4, 5. So the result is gonna be 0.258973. How about dividing it by a million this time, which has 6 zeros? It means we can move the decimal point to the left 6 times. And the last one doesn't have anything, so we can put 0 there. So the result is gonna be 0.0258973. Let's try to summarize what we learned so far. We went over the decimals in general, and then we went over their digits and positions in more detail. We also took a look at how to round decimal numbers, and how to shift a decimal point when multiplying or dividing with powers of 10. So this video went over the basic concept of decimal. Make sure you're comfortable with this first, then try moving on to the next video.